Guys, let us look at question 3 of the November 2025. We're basically checking with our candidate as to did they do it correct or they made a lot of mistakes. Question 3, it's based on vertical projectile. There's a given statement here. A ball is projected vertically upwards from the top of a building that is 5 meters high. Ignore the effect of friction. That's the given diagram. That's the ball thrown vertically upwards. That's what they said to us. And then from this building, which is 5 meters above the ground. Then now they said the table below shows the magnitude of the velocity of the ball at 3 different times during its motion. So this was the given table. We can see that when the time is 0 seconds, now we know that there is a velocity of 15 meters per second. Now, meaning the 15 meters per second, that will give us the initial velocity. And then when the time is per second, now we know that the velocity at that point at 0 meters per second. So as a learner, as a candidate, you are supposed to remember all the basics, saying that it can only be at the maximum point where the velocity is at 0 meters per second. Now when the time is 3,36, then the velocity is the velocity is q. Then now let's try to attempt the questions. The first question that was given to the candidate, it was 3.1, define the term free fall. So we know that when checking a free fall, we're basically talking about the motion or the movement of an object under the influence of the gravitational force only. So that 2 marks was freely given to each and every candidate who was writing their final examination yesterday. And then 3.2, using equations of motion only. So when they said using equations of motion only, the basically are saying to you go for V final equals to V initially plus the acceleration multiplied by the change in time. They were saying to you go for V final squared is equals to VI squared plus 2G delta Y. The third one, it's delta y equivalent to VI multiplied by delta t plus 1 over 2g delta t squared. The last one, delta y equivalent to, in brackets, VI plus VF all over 2 multiplied by delta t. Now they say use equations of motion only, calculate the value of the value of P for 3 marks. So they were looking for the value of P. So P, basically P, it's the time taken by the ball to move from the starting point here. The time taken by the ball to move from this starting point up until it reaches the maximum point. So basically, this is the situation we are looking for this time. This is what they were looking for, which is symbolized by Symbolized by P on the table. So what is it that we know? We know that as a starting point, we've got the initial velocity of 15 meters per second. That we know. Then we all know that at the maximum point, we've got the velocity of 0 meters per second. So what is it that we're looking for? We're looking for delta t. And then we know that this ball is in free fall. Therefore, now it's going to experience the gravitational acceleration, which is equals to 9.8 meters per second squared. Of course, this one is always acting where? It's always acting downward. So now together, let us fall for upwards as positive. If we are falling for upwards as positive, it means everything that is below the starting point, then it's gonna be it's gonna be negative. So in this case, what are we taking? We are taking the final velocity is equal to the initial velocity plus our g delta t, or it can be a delta t, so it's fine. So the final velocity is 0. The initial is 15 positive because upwards is positive plus into negative 9.8 being multiplied by delta t. So why is the g negative? Because the g is below the starting point. So we are having 9.8 delta t equivalent to 15. Everything must be divided by 9.8 so that we can solve for that which they were looking for. So it's 15 divided by 9.8. What is delta t. So the time is 1,530 second. Therefore now it means the value of p in this case it's 1,530 second for 3 marks. This is how you were supposed to attempt this question. And then now there's a statement beneath the ball strikes the ground 3,3 seconds after it was thrown upwards. So this is the time taken by the ball to strike the ground. It means your Q, it can only be the velocity with which the ball strikes, the ground. Then now they say to us, calculate Q. So in finding Q, like I've been saying, your Q is going to be your final velocity. So we've got a lot of information. We've got, what are we having? We've got the initial velocity. The initial velocity is the starting point. It's 15 meters per second that we know. That's the initial velocity. And then again, we've got our G of 9,8 meters per second squared. And then again, what are we given? We are given delta T, which is 3,36 seconds that we know. And then again, what is it that we are looking for? We are looking for the final velocity. So again, if we are saying upwards as positive, it means our G, it's gonna be what? It's gonna be negative because our G, it's below the starting point. And then we're also expecting our velocity to be negative because it's also below the starting point. So in this case, with this given information, there's a lot of information here. Again, we can even rely on the height of the building. Delta Y, it can be 5 meters. We've got too much information here. It will depend on the candidate, or we can choose an equation that we can apply in this case. We can apply this one. Finally, velocity squared is equals to initial velocity squared plus 2g delta Y. We are applying this one. Correct substitution, we are having 15 squared plus 2 into negative 9,8 into negative 5. Because G and the height of the building, they are both below the They are both below the starting point. So V final is equal, it's equal. So we punch our calculator. We're having 15 squared. We are having 15 squared, and then being added to 2 into negative 9,8 into negative 5. Close. So the answer is here, it's 323. Then we squared both sides. So that V finally is equivalent to, remember, the square root. What is the square root? Where is the square root here? Square root of 323. This one, it's giving us 17,97 meters per second. Mind you, this one is going to add where? It's going to add downwards. So this is how you are supposed to attempt this question, simple like that. Then we proceed trying to solve everything that they are looking for. So this is 17,97 meters per second. Let me remove this here to create some space for myself. Now let's proceed looking at the next question. So the next question is saying to us, the ball bounces to a maximum of 3 meters. Remember, initially the ball is thrown from a height of 5 meters. Then it strikes the ground. After striking the ground, it bounces off the ground. After bouncing off the ground, then the ball couldn't maintain the initially high. So meaning there's a decrease in what? There's a decrease in height. Now, after it strikes the ground, 3.4, is the collision with the ground elastic or inelastic? Explain the answer without the use of what? Calculation. So the correct answer there is what? Inelastic. That's the correct answer. It is inelastic. Why inelastic? The first thing that you can say as a candidate or as a learner, the kinetic energy, of course, of the ball is not what? It's not conserved. Tick number 2. The correct answer is inelastic. The kinetic energy of the ball, it's not conserved. Now we're explaining why we're saying it's not conserved. We can say that it is because there's a loss in kinetic energy, where some of the kinetic energy, right, it's converted to some other forms, or some other forms of energy, such as what? Such as heat or what? Or sound. So then now, as a result, since there's a loss in mechanical and in kinetic energy, it means there was not enough energy to convert the what? To convert the mechanical energy back to its original. That is why there's a decrease in what? There's a decrease in height there. So those are the things you were supposed to pay attention to when you were explaining such question. Like I've been saying, in elastic, kinetic energy is conserved. Some of the energy it's converted to sound or light, meaning there's a loss in what? There's a loss in kinetic energy. Once there's a loss in kinetic energy, automatically there'll be loss in the what? In the mechanical energy of the what? Of the board. That is why it couldn't maintain the original height of 5 meters. Then 3.5. Sketch a velocity versus time graph for the motion of the ball from the time it was projected until it reaches the maximum height after it bounces. Okay, show the following numerical values on the graph. The initial velocity time p, velocity p. They are saying for the motion of the ball from the time it was projected until it reaches the maximum height after it bounces. So in this case, what is it that we're going to do here in throwing our velocity time graph? It's simple. And finding our velocity time graph, it's very simple. Mind you, we know this one is 1,53, and then we know this one is 17,98 meters per second. So we're going to throw our velocity time graph. There we go. That's our velocity time graph. This is our velocity time graph. So there's one mark for labeling of the axis, which is your y-axis is velocity, meters per second, and then your x-axis, of course, it's time in what? It's time in second. So we said upwards is positive, so the initial velocity, it's gonna be what? It's gonna be positive. Then the final velocity striking the ground at minus 17,97. So the time taken to reach the maximum point, which is the what? The 1,53. Simple like that. And then from then it bounces off. Unfortunately, we do not know that velocity, but we know that it bounces off. And then now let's go. What are we having? It is thrown vertically upwards up until it reaches the what? It reaches the maximum point. At the maximum point where the velocity is 0, and then from there it went to strike the ground at that velocity. And then after striking the ground, we all know that this ball bounces off. Unfortunately, we do not know the velocity with which it bounces off the ground. So we can label that one to be what? To be the earth, our x. So x is the velocity with which the ball bounces off the ground. So this is what was expected of you as a candidate for 4 marks. The total for question 3, it was 15 marks, which was also very fair given to learners. Thank you for watching. Please follow me for more as we proceed discussing question 4, 5, 6 until to the last page of our question paper.